Today we're talking about Goosebumps. I came across this article a little while back, and at a glance, researchers discovered a new role for Goosebumps. The muscles and nerve cells involved in this response to cold trigger new hair growth by activating stem cells, and these mechanics may also have implications for reversing hair loss and understanding wound healing in the skin. So let's dive in. Even though humans have evolved to have relatively little body hair, we still produce goosebumps when cold, and goosebumps occur when tiny muscles in our skin hair follicles called erector pili muscles pull hair upright. Now, for animals with thick fur, this response helps keep them warm, but it doesn't do so for people. Naturally, since we're less hairy. Still, this ability to make goosebumps persist in humans and other animals that don't have enough hair to retain warmth. The research is led by Dr. Yache Husu from Harvard University. Not sure if I'm saying that right. Might be butchering it. I butcher names, even easy ones, so that's just on me. And Sungyan Lin from National Taiwan University used skin samples from mice to explore what other roles goosebumps might play. Now, previous research identified a trio of cell types that work together to create goosebumps: erector pili muscles, sympathetic nerves, and their hair follicles. The work was funded in part by NIH, National Institute of Arthritis and Musculoskeletal and Skin Diseases, NIMUS, and National Institute of Diabetes and Digestive and Kidney Diseases. Results were published on July 15th, 2020 in Cell. The team first used drugs and genetic models to remove sympathetic nerves from the skin. In response, hair follicle stem cells were slow to activate and new hair production was delayed. Further experiments show that removing sympathetic nerves and reduced the amount of a chemical called norepinephrine in the skin. Norepinephrine is a type of neurotransmitter, a substance that nerve cells use to communicate. When the team produced mice with hair follicle stem cells that lacked a receptor for norepinephrine, activation of the stem cells was delayed, similar to when sympathetic nerves were removed. And the researchers next used electron microscopy to generate extremely high-resolution pictures of the hair follicles. The sympathetic nerves were not only intertwined with muscle, but also interacted with the stem cells. Further imaging showed that the ends of the nerves and the stem cells form synapses, which let cells communicate chemically. Finally, the team teased out the role of the muscle cells and the follicles. They used two different techniques to destroy erector pili muscles in the skin while leaving nerves and stem cells intact. Without the muscle cells, connections between the nerves and stem cells were lost, and the mice showed a delay in both stem cell activation and production of new hair. Based on these results, the researcher proposed that the muscle cells form a bridge between the nerve and the stem cells and the hair follicle. In this way, goosebumps might play two roles. They cause hair to rise in the short term and trigger more hair growth by the stem cells in the long term. To test this idea, the research compared mice exposed to either cold or normal room temperature. The cold exposure first caused goosebumps, then boosted activity in the sympathetic nerves and an increase in norepinephrine. Mice exposed to the cold started to produce new hairs from their stem cells in less than 2 weeks. It's a two-layer response. Goosebumps are a quick way to provide some sort of relief in the short term. When the cold lasts, this becomes a nice mechanism for the stem cells to know it's maybe time to regenerate new hair coat, says Dr. Julia Swartz, a postdoctoral researcher in the Husu lab, who is the first author of the study. Erector pili muscles are often lost in the scalps of people with common baldness, and finding a way to reactivate the sympathetic nerves in the hair follicles despite this loss may provide a way to boost hair growth. The team is also interested in studying whether these interactions might play a role in other processes in the skin, such as wound healing. Now, does this research actually hold any value? And the answer is yes. I did not know this before I started doing research on this. That there is actually a market for this. The global hair loss treatment product market is expected to reach, 934 million by 2023, which is kind of crazy. And there's more than 80 million men and women in North America that suffer from hair loss problems. Consumers are also seeking products with active ingredients to treat hair loss problems. And according to the American Hair Loss Association, more than 66% of men are expected to experience hair loss problems by the age of 35, which is crazy. Now, there's a whole bunch of different reasons as to why, and different types of hair loss as well. The most common ones I would probably say is androgenic alopecia. Now, it affects more than 50 million men and women in the United States. commonly known as male pattern hair loss or female pattern hair loss. Now, it can be managed with medication or surgery, and it's hereditary, so you can get it from your family, which is a nice little gift, I suppose. Yes. I mean, I'm cracking jokes, but people in my family, especially males, they have a thinning hairline. If we live long enough, I suppose it'll happen. So this might be a personal story for me as well. Right now, full head of hair. Who knows? And given enough years, who knows what's really going to happen? Some of these things actually surprised me, though. So, alopecia areata is an autoimmune condition, which means the body's immune system attacks healthy tissue, including the hair follicles. This causes hair to fall out and prevents new hair from growing. Now, their market cap is said to be 5.3 billion, which is crazy. By 2027. It's bizarre. So that's our own immune system attacking healthy tissue and also hair follicles, which is causing spots where you don't have hair. As it says, this condition can affect adults and children, and hair loss can begin suddenly and without warning. Hair from the scalp typically falls out in small patches, and it's not painful. Hair in other parts of the body, including eyebrows and eyelashes, may also fall out. Over time, this disease may lead to alopecia totalis or complete hair loss. Dermatologists treat alopecia areata with medication that may help hair regrow. So, yes. There's also a support group as well for this. This is the thing that fascinates me about the world. Very often, I find myself in my own little bubble, and it's always intriguing to look behind the veil and learn new things. So, yeah, this is where my brain went for quite some time. There are, of course, other ways that you can lose your hair. A bunch of this different ways. So many different ways, more than I ever thought was possible. But there's certainly markets, and it'll certainly help for some of these things. It might not help for all of them, but even so, interesting read for me anyways. I hope you guys have a good one, and bye-bye.